Hello friends, I welcome you all to this class. This is linear algebra class, and today we'll be solving this question under this theorem we introduced in our last class, Cayley-Hamilton theorem. So in this example, they asked us to use the Cayley-Hamilton theorem to find A inverse, where A is this 2 by 2 matrix. So the matrix must be a square matrix. So you can see that this is a square matrix. This is 2 by 2 matrix. So the matrix must be n by n matrix. Either 2 by 2 or 3 by 3 or 4 by 4, as the case may be. So but it should be a square matrix. Then it must satisfy its what characteristic equation. That's what Cayley-Hamilton theorem says, that every square matrix will satisfy its what characteristic equation. Because of that, we need to compute the characteristic equation of this matrix and use the knowledge to find A inverse. Solution. So to compute the characteristic equation, we must first of all solve this determinant of A minus lambda I equal to 0. So we'll solve this. So this will be equal to determinant of A is 1, 1, negative 1, 3 minus lambda. I is the identity matrix. Since matrix A is 2 by 2, the identity matrix also will be 2 by 2, 1, 0, 0, 1 equal to 0. So this will be equal to this implies determinant of 1, 1, negative 1, 3 minus, so let's multiply lambda multiplied by 1, lambda multiplied by 0, 0, lambda multiplied by 0, 0, lambda multiplied by 1, lambda, determinant equals to 0. So this is what we have. So this implies determinant of, let's subtract 1 minus lambda, 1 minus lambda, 1 minus 0, 1, negative 1 minus 0, negative 1, 3 minus lambda, 3 minus lambda, determinant equals to 0. So this implies, this is a 2 by 2 matrix. So to find the determinant, you multiply the principal diagonal first. 1 minus lambda multiplied by 3 minus lambda. Then you subtract the product of the other diagonal. Negative 1 multiplied by 1 is what? Negative 1. So you'll be doing negative, negative. So which will be positive. So we are going to have positive 1 here equal to 0. So this implies, let's open the bracket. 1 multiplied by 3, 3. 1 multiplied by negative lambda, negative lambda. Negative lambda multiplied by 3, negative 3 lambda. Negative lambda multiplied by negative lambda, positive lambda squared, plus 1 equals to 0. So this implies, let's write the one with the highest, lambda with the highest degree. That's lambda squared. Then this one, negative lambda, negative 3 lambda, negative 4 lambda. Then let's write the constant. 3 plus 1 is 4, positive 4, equals to 0. So this is what we have. Then by the Cayley-Hamilton theorem, this matrix will satisfy its what? Characteristic equation. So P of A, so we'll plug in matrix A for lambda. So you replace lambda with matrix A, that's we have A squared minus 4A. 4 is the constant, right? Since 4 is the constant, and you want to add it with this matrix, so you need to, you cannot add a constant in a matrix, so you have to multiply this constant by what? Identity matrix, so that you can be able to add it with this matrix. So you are going to have plus, instead of plus 4, you have plus 4i. So whenever you are adding a matrix and a constant, you must multiply the constant by identity matrix for you to be able to add it. Then equal to, will equate to 0, because this is supposed to satisfy what? It's supposed to satisfy this equation by Cayley theorem. So we now use this Cayley theorem, this knowledge, to find A inverse. So for you to do that, you multiply both sides. Whenever you want to find the inverse of this of a square matrix using Cayley's theorem, when you have gotten the characteristic equation, you have substituted A for lambda, and by Cayley's theorem this equation will be satisfied. What you are going to do, you multiply both sides. Multiply both sides by A inverse. When you multiply both sides by A inverse, this implies multiply A squared by A inverse, you have A. Multiply negative 4A by A inverse, you have negative 4. You would have had what you're supposed to have in actual sense. You would have negative 4 alone, but we'll be adding it with matrix A, right? So you are not going to have negative 4, you are going to have negative 4i, because we can't be adding a constant and a matrix, or subtracting a constant and a matrix. So I have negative 4i. Then positive 4i multiplied by A inverse, you are going to have 4A inverse, then equal to 0 multiplied by A inverse, 0. So make A inverse the source of the formula. So to make it source of the formula, we can move every other term to the other side, right? This implies 4A inverse will be equal to, move this to the right, have negative A, move this to the right, have positive 4i, right? Then divide both sides by the coefficient of let's create space. Next step, you are going to do what? Divide both sides by the coefficient of this 4. That's coefficient of A inverse. So divide both sides by 4. So if you divide both sides by 4, so this implies what? Dividing both sides by 4 is same thing as multiplying both sides by 1 over 4. So that is the reciprocal of 4. So if you do that, you have A inverse equal to, do that here, is same thing as say 1 over 4 multiplied by negative A plus 4i. So this will give us the inverse of this matrix. So this will be equal to 1/4 of negative A. So we have negative of, what is our matrix A? 1, 1, negative 1, 3, plus 4. I is the identity matrix. It will be 2 by 2 because matrix A is 2 by 2. This is identity matrix. Identity matrix is just a matrix in which the other entries, that is the principal diagonal, have 1 as the entries throughout. So in the principal diagonal, you have 1 throughout. Then all other entries outside the principal diagonal will be 0. So in other words, identity matrix is a diagonal matrix having unit entries throughout its diagonal. So this will be equal to 1/4 of negative 1 multiplied by positive 1, we have negative 1. Negative multiplied by positive 1, negative 1. Negative multiplied by negative 1, we have positive 1. Negative multiplied by positive 3, we have negative 3. Plus 4 multiplied by 1, 4. 4 multiplied by 0, 0. 4 multiplied by 0, 0. 4 multiplied by 1, 4. So this is 1/4 of, let's add 1/4 of, let's add negative 1 plus 4 will be what? 3. Negative 1 plus 0 will be what? Negative 1. 1 plus 0 is what? 1. Negative 3 plus 4 will give you what? 1. So this will give you the inverse of this very 2 by 2 matrix. So thank you so much for being part of this class. See you in our upcoming class.